Okay, let's journey back. Picture the early Jurassic, the dawn of the dinosaurs, really. You've got these giant plant eaters, scary predators, but what about the smaller guys?
Right, they often get overlooked. But today, we're zeroing in on one of those, Abrictosaurus. It might seem small, but it's actually packed with some surprising features.
And secrets, yeah, it sounds like it. Abrictosaurus. Even the name wakeful lizard kind of hints there's a story there. We'll get into
We
that.
will. And yeah, size-wise, we're talking maybe 4 feet long,
Yeah.
probably less than 100 pounds. So, not exactly a giant.
Right, like a medium-sized dog, maybe, but definitely not insignificant in the grand scheme of things.
Not at all. So for this deep dive, we're basically looking at the science, the discoveries, how it got its name, which is a bit of a saga, its physical traits, and these ongoing debates about, well, things like whether males and females look different.
Okay, so the mission is really to understand what makes this little dinosaur important, right? For figuring out early dinosaur evolution and I guess how science even works sometimes with new finds changing things.
Exactly. It's a great case study for that.
So, discovery. Let's start there. It wasn't like they found a perfect skeleton lying there, was it?
Oh, definitely not.
Yeah.
Abrictosaurus is actually only known from 2 individuals, just 2.
Wow, only 2. That's not a lot to go on.
It really isn't. And that scarcity is, well, it's a big part of why there are still some questions floating around.
Okay, so where did these crucial 2 fossils turn up?
The first one, the main reference specimen, we call it the holotype that was found in Lesotho, specifically in the Upper Elliott Formation and the Kacha's Neck district.
Okay, Lesotho. And the second one?
The second was also from the Upper Elliott Formation, but this one was found in the Cape Province of South Africa. So same geological layer, slightly different location.
Gotcha. And timeline-wise, we're talking early Jurassic. Like, how early?
Very early, the Hatangian and Cinemerian stages.
Yeah.
So roughly 200 to 190 million years ago, right near the beginning of the Jurassic period, Pangaea was just starting to split up around then.
Wow. Okay, so what was it like there back then, Southern Africa, 190 million years ago? What kind of world was it living in?
Well, the evidence points towards a semi-arid environment, think sand dunes, but also floodplains that probably saw seasonal rain.
So not exactly a lush jungle, maybe a bit tough.
Yeah, likely sporadic rainfall, maybe challenging conditions at times compared to, say, later dinosaur habitats we often imagine.
And who else was living there? Did Abrictosaurus have predators to worry about or competition?
Oh, definitely. The fossils from the Upper Elliott show a really interesting mix. You had Megabnosaurus, which was an early meat eater, a theropod.
Okay, so predators were around.
Yep. And then there was Massospondylus, a much larger plant eater, one of those early long neck types, a sauropodomorph. And interestingly, other related dinosaurs, other heterodontosaurids like Heterodontosauris itself, and Lycarhynus were also found there. So a few different types of these early ornithischians sharing the space.
So its own relatives were nearby.
Right. Plus, you had other creatures, too, like early croc relatives, terrestrial crocodilomorphs, and cynodonts, those mammal-like reptiles, and even some very early mammals settling around. It was quite a diverse ecosystem.
It really paints a picture. Okay, so let's place Abrictosaurus formally. Where does it sit in that big dinosaur family tree, classification-wise?
Right. So, broadly speaking, Eukaryota, Animalia, Chordata gets us to Dinosauria. Within dinosaurs, it's an ornithischian, the bird-hipped ones.
Bird-hipped.
But then we narrow it down. Family Heterodontosauridae, the different toothed lizards, subfamily Heterodontosauridae, and finally, genus Abrictosaurus, species Consors. It's seen as a pretty early or basal member of that Heterodontosauridae family.
Heterodontosauridae. Different toothed lizards. That name must be key, right? What's the standout feature?
It is. The name really says it all. Their defining thing is, well, heterodont dentition. They had different kinds of teeth in their mouths, specialized for different jobs.
Ah, not just rows of the same peg-like teeth.
Exactly. This was a big step for early plant eaters.
So what kind of teeth did Abrictosaurus have? What was in its toolkit?
Well, first off, right at the very front, no teeth. It had a hard beak, probably covered in keratin, like a bird or turtle beak. Good for snipping off plants.
Okay, a beak. Makes sense for herbivore. Then what?
Then, just behind the beak, in the upper jaw, on the premaxilla bone, it had 3 teeth. The first 2 were kind of small, cone-shaped.
Okay.
But the third one, that one was much bigger, like a tusk, an upper caniform.
A tusk on a plant eater.
Yeah, it's one of their most distinctive features.
Yep.
And the lower jaw had one too, often even bigger. It was the very first tooth on the main lower jawbone, the dentary, a lower caniform.
Tusks. Top and bottom. Okay. And further back for chewing.
Exactly. Further back in the jaws, you had rows of wider, flatter cheek teeth. Those were for grinding up the plant matter it snipped off with its beak.
So beak for cropping, tusks for, we'll get to that maybe, and then grinding teeth.
Pretty much. And there's one more detail in the upper jaw, a gap. A diastema, we call it. It was right where that big lower tusk would fit when the mouth closed.
Ah, like a custom-made slot.
Hmm?
Clever. Now, you mentioned its relatives, like Heterodontosaurus. How did Abrictosaurus's cheek teeth compare to theirs? Was there a difference there?
Yes, and it's quite significant. Like Cornus and Heterodontosaurus, they had cheek teeth that were high-crowned and packed really tightly together. They formed this continuous shearing or grinding surface, almost like the dental batteries you see in later duck-billed dinosaurs. Very efficient.
Okay, like a solid wall of teeth.
Right, but Abrictosaurus, its cheek teeth were different. They were more widely spaced, and the crowns weren't as high. It's actually a setup that looks more like what you see in other, even more primitive ornithischians.
So Abrictosaurus might have been a bit less specialized in its chewing compared to its close cousins, retaining an older style.
That's the interpretation, yeah. It suggests that even within this early family, there were different evolutionary pathways being tried out for processing plants.
Fascinating. Okay, let's circle back to those tusks, because there was some confusion about them, wasn't there? A debate about whether Abrictosaurus even had them initially.
There absolutely was. So the initial thinking, based on that first specimen, UCLB 54, was that Abrictosaurus actually lacked tusks altogether.
And that was seen as primitive.
Yeah, some researchers thought, okay, no tusks, maybe this is very early, very basal form, even more primitive than the others. It seemed to fit its slightly simpler cheek teeth, too.
But that wasn't the whole story.
Not quite. Because later on, when the second specimen, UCLA 100, was studied more closely, it definitely had tusks, clear as day.
Okay, so specimen 2 had them. How big were they?
Pretty noticeable. The upper one was about 10.5 millimeters, so just over a centimeter. The lower one was even bigger, around 17 millimeters. So, yeah, definitely tusked.
So that kind of changed the picture. Why the confusion then? Was the first one just missing them, or?
Well, the first specimen, the holotype, UCL B54, it genuinely seems to lack them, or at least they aren't preserved or weren't developed. And that observation, that lack of tusks, is what led to that initial idea and also feeds into another hypothesis about maybe males and females being different.
Right, we'll get to that. But the presence in the second specimen confirmed tusks were part of the Abrictosaurus toolkit.
Exactly. And there was another subtle difference, too. The serrations on the tusks. You know, the little steak knife edges?
Yeah.
In Lycorhinus and Heterodontosaurus, the tusks have serrations on both the front and back edges. But in Abrictosaurus, or at least in UCL A100, the serrations were only found on the front edge.
Huh. Only on the front. That's specific. Does that mean anything?
It's hard to say for sure, but it's another small anatomical detail that distinguishes it. Maybe it suggests a slightly different use or just a different developmental pattern. These tiny details are often the clues we have to work with.
Absolutely incredible. Okay, besides teeth and tusks, any other key physical differences between Abrictosaurus and, say, Heterodontosaurus?
Yeah, a couple things. The forelimbs seem to be smaller and maybe less powerfully built in Abrictosaurus compared to Heterodontosaurus.
Smaller arms. Okay.
And there's also a difference in the finger bones, the phalanges. Abrictosaurus had one fewer bone in its fourth and fifth fingers.
Fewer finger bones. Does that suggest anything about how it used its hands? Or how it moved?
It might. Maybe it relied more on its back legs for getting around, more bipedal. Or perhaps its forelimbs weren't used as much for grabbing food or other tasks compared to Heterodontosaurs. It hints at subtle lifestyle differences.
Okay, so we're building this picture. Small beak, unique teeth, sometimes tusks with front-only serrations, smaller arms. Now, the name, wakeful lizard. Let's unpack that. It sounds like there was some scientific back and forth.
Oh, there definitely was. It's a great example of scientific debate. So the first specimen, UCL B54, the one initially thought to be tuskless. It was described back in 1974 by Richard Tholborn.
Okay.
But he didn't call it Abrictosaurus. He actually thought it was a new species of an existing genus like Lycorhinus. He named it Lycorhinus consors.
Lycorhinus consors, and consors means like companion or spouse.
Exactly. Because Tholborn saw it lacked tusks, and he knew other Heterodontosaurids did have tusks, he made an analogy. He thought, well, maybe tusks are a male trait, like in some modern animals. So he proposed this tuskless one was the female counterpart, the consort or spouse of the tusked Lycorhinus.
Ah, I see. Makes sense based on what he saw. But then someone disagreed.
Right. Enter James Hobson just a year later, 1975. He was looking at that other skull fragment, UCL A100. Thalborn had also put that one tentatively into Lycorinus, but Hobson looked closer and thought, hang on, this skull, UCL A100, looks a lot like Thalborn's Lycorinus conser specimen, UCL B54.
Okay.
And crucially, Hobson didn't buy Thalborn's interpretation that the lack of tusks in B54 automatically made it a female Lycorinus. He saw enough unique features shared between the two specimens, B54 and A100, to say, no, this is something different. This deserves its own genus. And that's when he created Abrictosaurus.
Abrictosaurus. And the wakeful lizard part, where did that come from?
That was actually a direct response to another idea Thalborn had. Thalborn had suggested that maybe Heterodontosaurids estivated basically went dormant, like a hibernation, maybe during dry seasons.
Ah, okay.
Hobson wasn't convinced. So by naming it Abrictosaurus, wakeful lizard, he was sort of pushing back, making a statement that, no, these animals are probably active, awake creatures. The species name consers was kept, though, so it became Abrictosaurus consers.
Wow. A scientific argument right there in the name. That's brilliant. Did Thalborn ever come around to the new genus?
Not entirely, no. He apparently continued to argue for a while that they should all just be different species within the genus Lycorinus. But most paleontologists today follow Hobson's classification and keep Abrictosaurus, Lycorinus, and Heterodontosaurus as separate genera.
It shows how classification isn't always set in stone, doesn't it? Especially with fossils.
Absolutely. Defining species and genera in deep time with limited remains, it's inherently tricky. Interpretations can differ.
And what about that random tooth from Switzerland? Late Triassic, supposedly Abrictosaurus.
Yeah, that pops up occasionally. But it's really just an isolated tooth from much older rocks. It doesn't have any truly unique features that scream Abrictosaurus or even definitively Heterodontosaurid. So that link is generally considered very weak, pretty much discounted now.
Okay, got it. So let's get back to the main event. The tusks, or lack thereof, in those two key specimens. The sexual dimorphism idea, males having tusks, females not, versus maybe it being about age.
Right, that's the core debate now. The sexual dimorphism hypothesis was appealing early on. You know, we see tusks in male deer, male pigs, walruses.
Yeah.
They use them for display, fighting rivals, maybe defense.
Makes intuitive sense.
It does. So the idea that the tuskless UCL B54 was female seemed plausible, especially when first described.
But then UCL A100 turned up with tusks. Did that kill the dimorphism idea?
Not entirely, but it complicated it. It confirmed that the species Abrictosaurus consers could have tusks, but it didn't automatically rule out that some individuals, maybe females, lack them. However, another explanation started to look more likely.
Which was?
That UCL B54, the tuskless one, might actually be a juvenile, a young animal.
Ah, okay. What's the evidence for it being young?
Well, a couple things in its skeleton. Its skull seems to have a proportionally shorter face compared to UCL A100, and maybe more importantly, its sacral vertebrae, the bones that fuse together to form the sacrum in the hip area, they aren't fully fused together in UCL B54.
And unfused hip bones usually mean not fully grown.
Exactly. It's a common sign of skeletal immaturity in many vertebrates, including dinosaurs. So if B54 was a juvenile, then maybe the tusks just hadn't erupted yet or weren't fully developed. That happens in some animals today. Tusks come in later.
So the lack of tusks might just be an age thing, not a sex thing?
Precisely. It weakens the argument for sexual dimorphism being the only explanation for the difference between the two specimens. It could just be growth stages we're seeing. Or potentially a combination of both age and sex could be involved, but with only two fossils. It's really hard to say definitively.
Yeah, you really need more examples to see the pattern clearly. It's a fantastic illustration of how science works with limited data, constantly refining ideas.
It really is. You have these fragments from millions of years ago, and you're trying to piece together not just what the animal looked like, but aspects of its biology, its life history, its detective work.
Well, this has been absolutely fascinating, getting to know Abrictosaurus, this small but really significant dinosaur.
Absolutely. It's a key player from the early Jurassic in southern Africa. We've got its heterodont teeth, that beak, the whole tusk debate, whether that's about sex or age. It packs a lot of interesting questions into a small package.
And it really drives home how paleontology isn't static, right? New finds, new analyses, they can completely shift our understanding. Even for dinosaurs we thought we knew reasonably well.
Couldn't agree more. Abrictosaurus is a perfect example of that ongoing process of discovery and reinterpretation.
It makes you think, doesn't it? How much we can figure out from just a few bones, but also how much might still be hidden. What else could future finds tell us about Abrictosaurus and its world?
That's the exciting part. Every new fossil has the potential to add another piece to the puzzle, to maybe finally solve the tusk mystery, or tell us more about how these early ornithischians diversified. It really leaves you wondering what's still out there, waiting to be discovered.